So the virtual environment that I was mentioning, if you don't know, is a self-contained sandbox environment just for your application. So this is like a tiny little sandbox with a Python install and nothing else in it. And so it only has the packages that you specify, and they're distinct from the system ones. So if you want just the stuff for your application, you can build it in that virtual environment. So they're somewhat complex and weird to work with because they have weird names and all this kind of stuff. But they're really, really important for deployment and development. And there is a tool called virtualenv to create and manage them. But there's a new tool that combines pip and virtualenv together, since they're really sort of two sides of the same coin, and that's Pipenv. And so this is the new community standard. The Python Software Foundation is endorsing this as new community standard application, and this combines pip and virtualenv and like extends their functionality in a single app. So you can install it here. I've already got it installed on mine. And what that will do is that you can then use it to initialize an environment. So if you wanted, you can do a clean Python 3 environment with just pipenv3, but you can also use it to manage the and install the dependencies for your application. So if you have a pip file, so pip file is like a requirements.txt, but with a little bit more info. So we could generate it one from the requirements.txt that we had using the following command, pipenv install. Now I already have in the repo, I put it there for convenience, the pip file. So we'll just go take a look at it quick here. So see if that's, oops, doesn't want to auto-complete it. So if you look at the pip file there, you can see that it has essentially the same in the packages section here. So right here, it has essentially the same information that was in the requirements.txt, which is specifying those exact versions of Flask and NumPy and TensorFlow. But it also has additional sections here that give me more information. So if I didn't have a pip file, I could have run pipenv install, and it would generate a pip file from my requirements.txt, and then it actually will go and create a virtual environment and install those install the dependencies in there. So then if we go back here, so you see that there's the pip file. So one of the things that extra functionality that it has is you'll notice that it allows you to designate the source. So this is like, where am I getting the information on my packages from? In this case, it's PyPI. But I also have the ability to have different sets of packages for development and then for production kind of thing. I can also specify things like what version of Python that it requires. So it gives me a little bit more control than what's in the requirements.txt, and gives me a little bit more sort of flexibility. It's designed to sort of capture all the possible use cases. So then the next stage is generating a lock file, right? So what we want to do is, this is the fully resolved dependency tree for our project. So in this case, we would run pipenv lock on there. And this is required for a deterministic build, because like I said before, if we don't run this, then we have an issue with possible dependencies of the packages that we have getting updated, all that kind of stuff. Now, I should give you a warning here that it is possible that pipenv lock may fail. It's not guaranteed to succeed. It could fail to resolve a dependency conflict. And what that means is that if package A depends on package B and package C depends on package B, but they depend on different versions, there's no obvious way for it to resolve that. And so what happens is that it will be like, you need to think about what's going to happen here, whether that's manually rolling the dice on updating one of the versions of the packages, or potentially patching out the conflicting functionality. There's all kinds of different ways to resolve it, but there's no guaranteed way for it to do it automatically for you. So that could fail. So if we look at our pip file at lock, it can take quite a while. So we have it there. So let's pip file .lock. So if we look at our pip file.lock, it's obviously a lot more complex, right? It's got like gRPC in there. It has a whole bunch of hashes for known good versions. It's got all of the dependencies for all of these things. So this is really right here. This is all the information that we need to build a deterministic build, right? We need to be able to install protobuf and all this other stuff that wasn't in our pip file. So we need to make sure that we generate a log file.